All right, welcome to Unit 5 on sampling distributions. This is topic 5.2, the normal distribution revisited, and this is part B, right? Second video for this. So we're going to just dive right back into it. Remember, this video is really focusing on how we could use the normal model to help us find probabilities if a distribution follows a normal model. So now what we want to do is we want to talk about examining the extreme or the significant. Remember, this is a pretty big topic as we move forward. So based on the normal distribution, extreme or significant values fall way out on the lower or upper tails. A value could be extremely low or extremely high. So please keep in mind that that word extreme means one of two things. So if we're thinking about that normal model, extremely high are values way out here on the upper tail or values way down here on the lower tail. Now, in class, we've been discussing that we know that an extreme or a significant value has a probability that's either under 5% or under 1%, depending who you ask. I kind of prefer to go with the 1%, but a lot of statisticians go with 5%. So again, you got to remember that what does it mean to be a significant value? It means that the probability of you occurring or lower or higher is under 5 or 1%. So keep in mind that through technology, we can actually pinpoint these values that mark the extreme. But it's super important that you understand that when we're talking about the probabilities, we're not finding the probability of these extreme events or these extreme values. We're finding the probability of these extreme values or even more extreme, right? So when we talk about a value being right here, right, being extremely low, well, when we talk about that 1% probability, we actually mean 1% or more extreme, right? We're talking about 1% even lower than that value. Or if we want to go with 5%, if we're talking about that extreme significant top value, we're talking about any value in that top 5%. So again, it's not just a value, right? We're not just talking about one value. We're talking about any value in that top 5% or in that bottom 5%, or again, if you want to use 1%. So it's extremely important that you understand that what we're finding is the probability of an extremely significant value occur or more extreme. So even lower or even higher. And hopefully by the end of hearing all this, that'll make sense to you. All right, so for example, how much time would it take Josh to wash a car for it to be extremely large? So if we look at our normal model, remember that it's based on a mean of 15 minutes for Josh to wash a car and a standard deviation of 3.5. So if we look at this picture, we know that, anything above 3 is really, really unlikely, which again would be really extreme or really significant. So it's not so easy to just say 25.5, right? Because obviously 25.5 would be extremely high. It would be significant. If it took Josh 25.5 minutes to wash his car, that would be extreme to me. But what I actually want to find is, where does the extreme start? Where does it start? So to answer this, I need to do three things. First, I have to decide if I want significant to be the top 1% or the top 5%. Now, why am I saying top? Because it said an extremely large. So an extremely large would be somewhere up here at the top. All right, so honestly, I'm going to go with 1% as being extremely high. So what I want to find is what value marks the top 1%. Because again, if the probability of an event occurring is 1% or less, then that would be pretty significant to me. So what I now need to do is I have to find the z-score. I have to find the z-score that marks that top 1%. Where is it at? Well, it's not down here, right? These are very small z-scores that have a lot of probability above them. I'm trying to find a z-score that has 1% above it. So I need to find that value, and we should already know how to find that value. Remember, how do you find z-scores? Well, your calculator could do it for you using invert norm. Now, the last thing I have to do is, once I have that z-score, I have to convert it back to an actual time using the z-score formula. All right, so first off, let's quickly remind you how to use invert norm. So you're going to hit second vars to get invert norm. And remember, the only thing you have to type in when you use invert norm is the area below. All right, so if I'm talking about the most extreme 1%, what the calculator actually wants is the area below that, which would be the bottom 99%. Now, if the question was asking you about the extremely low, the lowest time it could take Josh to wash a car, then we'd be talking about the bottom 1%, and that's exactly what invert norm would want, the bottom 1%. But again, I'm focusing on an extremely high amount of time to wash a car. So I'm talking about the top 1%, but the calculator is going to think of that as the bottom 99%. All right. All I got to do is hit paste to enter that into my calculator, hit enter. There it is, 2.3263. So if I go back to this normal model over here, or the normal model, right here, 2.3263. So here's 1, here's 2, 2.3263 would be somewhere right around here. A z-score of 2.3263. That z-score would represent the top 1%. Well, all I have to do now is actually find the amount of time that is. And to do that, I just have to solve it using my z-score formula. So the z-score formula is really, really easy. It's right here. And I'm going to substitute in the z-score that marks that top value. Again, it's right around here, 2.3263. And now I just have to solve for what actual time that is. So I'm going to, I already know the mean is 15. I know the standard deviation is 3.5. So I'm going to start off by multiplying by the standard deviation, 3.5. Add the 15 over. You can actually type all of this into your calculator at once. It will do it in proper, order of operations for you. And I got 23.14. So 23.14 minutes would be the top 1%, right? So let's put all this together and make sure that you understand what we're saying. The probability that it takes Josh 23.14 minutes or higher to wash a car is 1%, right? Remember, the calculator cannot find individual probabilities with the normal model. So please do not say that there's a 1% chance that it takes Josh 23.14 minutes to wash his car. That's not true, right? It's 23.14 minutes or more extreme or even higher. Anything above 23.14 minutes would put you in that extreme, the top, that unlikely 1%. So if we were to take over 23.14 minutes to wash a car, this would be looked at as significantly high. I would wonder what the heck is going on. Remember, we do not believe that significant events occur. So when any significant event does occur, we've got to find an explanation. So let's just say that it took Josh, 24 minutes to wash a car. That would be extreme. That would be significant because it's above 23.14. So if it did take Josh 24 minutes to wash a car, I would say, whoa, Josh, there's got to be a reason why. Was it a super big car? Was it like a semi-truck that it took you that long? Was it super dirty? Like, did it just come back from some mud rally where it was filled with mud top to bottom, and that's why it took you so long? Or another explanation is maybe the mean of 15 was actually wrong. Like, he thought it was a mean of 15 minutes, but maybe that was wrong. I mean, think about this, right? If the 15-minute middle, the mean of 15 minutes was wrong, and the whole graph, the whole model was shifted higher, well, then all of a sudden, that 24 minutes wouldn't be so weird. So don't worry about too much of that right now. Just make sure you understand that what we're looking for is what would it take for something to be considered significant. And we found that to be 23.14 minutes or more. Don't just say 23.14 minutes. It's 23.14 minutes or more. All right. Now that we've done pretty much everything we could with the normal model, we talked about finding probabilities above, below, or in between. We talked about finding intervals with a given percentage, right? That middle 30% problem we did. And now we talked about finding the extreme. Let's kind of do a couple more practice problems to make sure everybody is really understanding this. And more importantly, what work needs to be shown. All right, so here's another example. Find the time that would mark an extremely low time to wash a car and describe what you found in context. All right, so we just found the extreme high. Now let's find the extreme low. All right, so let's see here. The first thing I have to do is decide, do I want the extreme to be the bottom 1% or the bottom 5%? Well, we just did the bottom 1%, so let's change it this time to the bottom 5%. So the first thing you have to say is, okay, I'm going to consider anything at that bottom 5% to be significant, right? To be extreme. All right, so what I need to figure out is what z-score marks that bottom 5%. And to do that, I'm going to go to invert norm on my calculator. And invert norm wants the area below. So if I'm looking for the bottom 5%, that's exactly what I type in. The only time you have to do the opposite is when you're thinking about the top extreme, but we want the bottom this time. So the z-score that would mark the bottom is negative 1.6449. So any z-score of negative 1.6449, I want to make sure I said that right. Yep. Anything below that would be extreme. So now all I have to do is solve for what value actually represents that. And I'm using my z-score formula because this is a z-score. So I'm going to take the negative 1.6449. The first thing I'm going to do is multiply it by 3.5. Then I'm going to add the 15 over, and I will get the value that marks the bottom 5%, or the most extreme, significant bottom 5%. So here I go. Negative 1.6449 times 3.5. Add the 15 over, and I get 9.24 minutes. All right, so if it were to take Josh under 9.24 minutes to wash a car, this would be extremely low. So there is a 5% probability that it would take 9.24 or more extreme, or lower in this case. And if that would happen, then again, that would be significant. I would wonder why. Why did it take you such a short amount of time? Maybe it was a smart car, a really, really tiny car, or maybe the car was actually pretty clean and to begin with and you just kind of sprayed it off with water. You know, there has to be an explanation for why it took you that short. Again, so it's really a three-step process. Step one, you have to say to yourself, what do you want to be extreme? 1% or 5%? Honestly, right now it's up to you. Then you just have to find the corresponding z-score, use the formula to solve. So this is the work that you would need to show. Really not too hard. All right, here's a second example. Let's totally change the problem around. No longer talking about Josh washing cars, just so we can use a different problem here. All right, for high school boys in a certain region, the amount they can bench press follows a normal distribution with a mean of 140.2 pounds and a standard deviation of 34.5 pounds. Okay. Now, what's important about this sentence is that it says it follows a normal distribution. If it didn't say that, all of the commands I've taught you in the calculator, throw them out the window. They cannot be used. So I know that my mean is 140.2 pounds and my standard deviation is 34.5 pounds. I could draw my pretty little picture if I wanted to, nice and easy, but let's actually dive into some questions. All right, what is the probability a high school from this region can bench press more than 200 pounds? All right, so the first thing I'm going to do is I'm going to write down what I'm looking for. I'm going to find the probability that a boy could bench press more than 200 pounds. All right, to answer this, I have to show my work. First thing I got to do is I got to show the z-score. So 140.2, again, I forgot what the mean was. 140.2 was the mean, divided by 34.5 is the standard deviation. All right, so I'm going to go to my calculator, 200 minus 140.2. Remember, hit enter first, order of operations, then divide by the 34.5, and I get 1.7333. All right, then this question that I'm asking you, bench pressing more than 200 pounds, would be equivalent to find the probability that a z-score is more than 1.7333. Now, to do this on my calculator, I am going to use normal CDF. I'm going to look from 1.7333 to infinity. I'm going to go way above, and I'm going to be thinking about this in terms of z-scores, which is a mean of 0 and a standard deviation of 1. Now remember, that's what your calculator is actually going to do. I'm just kind of setting it up ahead of time. So now when I go to normal CDF here, I'm going to do 1.7333, and I'm going to go to an upper value of 99, because again, I don't have the infinity button on my calculator, and paste that, which is again what I already typed in, and the probability is 0.0415. 0.0415. So if you were to consider significant as 5% or less, then this would be significant. A boy benching 200 pounds would be considered significant because the probability of being more than 200 pounds is, again, less than 0.041. It's less than 5% at 0.0415. All right, next question. What is the probability that a high school boy from this region can bench press less than 125 pounds? All right, let's walk through the process again pretty quickly here. We're trying to find the probability that the bench press is less than 125 pounds. Z-score is going to be 125 minus 140.2 divided by 34.5. And if you're bored with this, you could always pause, do the work, and then fast forward and check your answer if you want, if you think that you already know how to do all this. All right, divided by 34.5. I get a z-score of negative 0.4406. Notice I'm always around the 4 decimals for accuracy. So the probability that a bench press is less than 125 is equivalent to the z-score being less than negative 0.4406. That's going to be using normal CDF on my calculator. I'm going to go from a low of negative infinity because I'm looking lower, so I'm going to go way down to the z-score of negative 0.4406. Mean of 0, standard deviation of 1 for the generic normal model. Now I'm actually going to do that on my calculator here. And again, I hope you realize that this is actually pretty fast. If you know what you're doing, this goes really, really fast. So negative 99 is my negative infinity. Negative 0.4406 is my z-score. And 0.3298. So this would not be significant, 0.3298. So if a boy benched 125 pounds or less, that would not be significant. That would not be weird. That's, it just happens. In fact, it happens almost 33% of the time. It would not be weird for a boy to bench less than 125 pounds. In fact, it's pretty common. Look at the probability. All right, what interval would represent the middle 60% of weights a high school boy in this area could bench press? Okay, let's remember how to do this again. All right, couple steps here. First off, I'm looking for the middle 60%. So I like to draw a picture. Doesn't take a whole lot here to draw a picture. I'm looking for the middle 60%, which means that there's an outside 40%, but that outside 40% gets split up 20% and 20%. What I need to do is I need to find the z-score at the bottom of my interval, and I need to find the z-score at the top of my interval. To do that, I'm going to go to invert norm on my calculator. Remember, invert norm wants the area below. So to find the bottom would be putting in the 20% at the bottom, the 20% that's below my 60% interval. And I get negative 0.8416. Then I want to find the z-score that marks the top of my interval. And the area below my interval would be actually 80%. If again, look at my picture that I drew here. If I'm trying to find that top of my interval, I'm looking at the bottom 80%. But to be honest, I don't need to do this because look at my answer. Because of symmetry, if the bottom 20% is negative 0.8416, then the number at the top would be positive 0.8416. All right, so now all I got to do is I got to take those z-scores of negative 0.8416 and positive 0.8416, and I got to find the actual weight. So I'm going to use my z-score formula, which is the weight minus the mean divided by the standard deviation, and I simply have to solve each of these. And again, all I'm trying to do is find the actual weights that represent these z-scores, because then these will be the actual weights that mark the middle 60%. All right, so I'm going to take the negative 0.8416, multiply by 34.5, add the 140.2, and I'll get my answer for x. And then same thing over here, take the positive 0.8416, multiply by the 34.5, add the 140.2, and I'll get my answer on that side of the interval. So again, pretty easy to do this by hand. It doesn't take a whole lot of work to do. Using the calculator. Negative 0.8416 times 34.5 plus 140.2. And there's the bottom of my interval. And then what you can do is you can hit second enter and then just go back and change that negative in the very beginning. Just kind of delete it. Make it a positive. And now you'll get the top of your interval. So 111.16 to 169.24. So 111.16 to what was it again? I have a bad memory. 169.24. So anywhere in that region, if you could lift, if you're a high school boy and you could lift somewhere from 111 to 169 pounds bench press, you're in the middle 60%. All right, next practice question here. Would it be significant if a boy in this region bench press 190 pounds? All right, so would it be significant? So is this extremely high? Remember, what's the definition of extremely high? Right? To be extreme, to be significant. The definition of extreme, the definition of significant is that your probability is below 1% or below 5%, whatever you deem it to be. I'm going to go ahead and use 1%. If I truly want to call something significant, it needs to have a probability lower than 1%. So what do I got to do? I need to find the probability that a boy could bench press more than 190. If the probability a boy can bench press more than 190 is under 1%, then that would be very significant. All right, so what do I got to do? I got to find the z-score. 190 minus 140.2 divided by 34.5. Grab my calculator, get that z-score. Can't tell you how many kids don't divide, don't do the top first. Okay, that messes them up. 144.35. 1.4435. 1.4435. All right, so now I'm trying to find the probability that my z-score is more than 1.4435. I kept saying that wrong. And again, to get this probability, I'm going to use normal CDF. And I'm going to go from 1.4435 to infinity with a mean of 0 and a standard deviation of 1. That's, again, referencing my normal, standard, normal, generic model here. All right, so normal CDF, 1.4435 to 99. That's acting like my infinity. And again, I'm really emphasizing all the work I'm showing in this video as the work you need to show. The probability is 0.0744. 0.0744. All right, so is this significant? No. Again, the probability that a boy can bench 190 pounds or more extreme, right, or higher, is about 7%. So I don't think that that's significant. I don't think that that would be something that I would consider extremely heavy. It is up there. 190 pounds is pretty high, but I don't know I would officially deem that as a significant bench press weight, right? Again, 7% of boys lift more than that. So again, it happens, right? 7% is very, very likely. So if a boy said, I bench press 190, I'd be like, hey, good for you. I don't think you did anything that special. But again, I needed the probability to answer that question. All right. Next question. How much would a boy from this region have to bench press for it to be considered significantly high? Like, we just figured out that 190 pounds is not significantly high. So what would it take? All right. So remember, again, I'm going to go with my 1%. You got to make that decision. What do you think significant is? I'm going to go with 1%. So the first thing I need to figure out is what z-score represents that top 1%. All right, so here I go to invert norm. Invert norm is how you get z-scores. Please remember that the area at once is the area below. So if I'm trying to find the top 1%, I need to put in the bottom 99%. Please keep that in mind. Don't ever forget that. All right, so 2.3263. Some kids actually will just start to remember this z-score as the z-score for significantly high. Oh, and guess what? If that's the top 1%, what z-score do you think would represent the most extreme at the bottom? Well, because of symmetry, negative 2.3263. So some kids just start to kind of memorize this z-score. All right, so now if I'm a boy in high school and that's my z-score, oh boy, I'm at that top 1%. So now what I have to figure out is what actual weight is this. So I'm going to have to solve for this weight. So I'm going to use my z-score formula here. Of course, I'm showing all my work. So the first thing I'm going to do is I'm going to take the 2.3263. I'm going to multiply it by the 34.5. I'm going to add the 140.2, and I'm going to get my answer. I'm going to go back to my calculator here. 2.3263 times 34.5. Add the 140.2, and it's 220.46 pounds. So 220.46 pounds. So if I can lift 220.46 pounds or more, please do not forget the point or more. The or more, that's really important. If I can lift 220.46 pounds or more extreme or higher, then I would be considered significant. I would be in that top 1% of high school boys, and which would tell me I'm very strong, right? So again, if something significant happens, you got to find an answer. Why? Maybe I'm a really hard worker and I lift weights every single day. Maybe I got held back 5 years and I'm actually 22 years old and I'm in high school. Maybe I take steroids. You know, the point I'm trying to make is when something significant happens, there's got to be a reason. Don't always jump to a negative reason. Again, maybe this is the kids at high school that really work their butts off, and that's why they are the most extreme. All right. All right, I got one more problem for you in this video. Brand new topic. No longer washing car, no longer bench pressing. Now we're talking about fish. But this is a good problem that really makes you work your butt off to get the answer. All right. In a lake, lengths of fish follow a normal distribution. That's awesome. With a mean of 18.5 inches. All right, it is known that 12% of fish are above 25 inches. 12% of fish are above 25 inches. So that's not extremely significant or anything because 12% is not low, but 12% of fish are above 25 inches. All right, what percent of fish are below 15 inches? So the question they're asking me is what percent, what probability, what proportion of fish are below 15 inches. All right, so I'm thinking in my mind, how could I get this answer? Well, remember, hopefully I've taught you the first thing I need is a z-score. So I need to take 15, I need to subtract the mean, and I need to divide by the, oh boy, that's where I'm running into a problem. I need to divide by the standard deviation, but I don't know what it is. But please make sure you understand how easy this question is. Once I find that standard deviation, all I got to do is get my z-score, and then I can use normal CDF to get the answer. But how do I get that standard deviation? Because without that standard deviation, I cannot answer the question. Well, that's where this is going to help me. All right, let's use this to help me. Okay, a 25-inch fish is at the top 12%. I need to figure out what z-score that is. All right, what z-score marks the top 12%? Well, invert norm is how you get z-scores. Please keep in mind area is the bottom. So if I'm looking for the top 12%, that's the bottom 88%. So the z-score for this 25-inch fish is 1.1750. 1.1750. Now, why is this important? Because now what I could do is I could use my z-score formula, 25 minus the mean of 18.5, and I could solve for the standard deviation that I don't know that I need to put right here. All right, so again, basically I'm using some given information to calculate future information that I'm going to need, and that's the standard deviation. All right, so again, let me just quickly remind you what I did. I found the z-score that represents this 25-inch fish. How did I get that z-score? Because I know there's 12% above it, which means 88% below it. That's how I got my z-score. Now I'm going to solve. So I'm going to multiply by sigma. And on top there, I can actually do that math. That math's not too bad to do. I need to do my calculator, but I can still do it. 25 minus 18.5 is 6.5. Hopefully you guys could do that in your head, but I like to always check on my calculator. So therefore, the standard deviation is going to be 6.5 divided by 1.1750. So I'm going to go to my calculator, 6.5 divided by 1.1750. And I get 5.53 as my standard deviation. All right, now I'm going to do is come back over here. I'm going to now, that wasn't even the question, right? But I needed to do that to help me find my question. What's the probability of fish is less than 15? Well, now I just got to find the z-score for 15. Subtract the mean, divide by the standard deviation. 15 minus 18.5. Divide by 5.53. This fish has a z-score of negative 0.6329. Sorry. I'm really bad at writing sometimes. So answering the question about being less than 15 is the same thing as a z-score being less than negative 0.6329. To get that answer, I'm going to utilize normal CDF. Again, I'm showing all of my work. Please do this. I'm going to go from negative infinity, because I got a little below, to the z-score of negative 0.6329 using the standard normal model of 0 and 1. And again, that's going to be second vars, number 2 here. And again, I'm going to go negative 99 because I'm starting way low. up into my z-score of negative 0.6329. And paste that into the home screen, which is what I wrote down on the paper here, and I get 0.2634. So the answer to the question, 0.2634, there's about a 26% chance that a fish is below 15 inches in this lake. Great question, because finding the answer is pretty easy, but it's needing some extra information, and I needed to find that standard deviation. This is a great problem that throws a lot of new skills at you at once and really makes you think. All right, guys, so we've did part 1. We've now done part 2. There's actually one more part to this topic. You know, the normal model is a huge topic, so I really wanted to revisit it in detail. I don't want to be like other teachers that revisit it and expect you to remember everything. I want to be a good teacher. I want to revisit it by going over all of the details. So again, there's actually one more video for this topic to help you understand the normal model.